Hello and welcome back to the second video of my game engine video series. In today's video we're gonna start implementing a window, and a window is required to kind of like display something. We need a window. If we won't have a window, nothing will work. Now, a window is like a very, very core concept of the game engine. The window is kind of like the context where we draw in, the context on which we can receive mouse and keyboard input. Like everything that we have on the Windows side is going to happen in a window. This is why it's called Windows actually, because Windows is actually composed out of a lot of windows. At least for the shell and for the user point of view, right? Your desktop is more or less a window, even though I think this is not 100% correct these days anymore. Okay, so yeah, how do we implement a window? Now, first of all, what I want to do is I want to separate the interfaces and implementations. So the first thing that I want to do is I want to delete out everything that we had in these projects, because this was just some stuff that we used to get it started. Now, what I want to do inside of the engine core is I want to define a window interface. So inside of the engine core, we're going to have an window.h. This is going to define how a window works. So namespace is going to be engine. I don't really care naming the engine, so I just put everything in the engine namespace for learning purposes. This is everything that you should need to be concerned, actually. Okay, so I want to write a class window. That's it. And just to make sure that this one works properly, let's make a virtual default destructor, just how we like to roll. And then let's write some description. So represents the window the game can run in. So in the end, what I want to have is like one window that handles all of the interactions for the game. Now, how do I implement the window? What functions does the window need? Now, the window in the end will have a lot of functions, and we will kind of like update the interface a lot. But for the starter, we just need to think about the obvious facts that the window has. Now, obviously, if we want to write a game, we more or less just need to know how big the window is, and depending on how big the window is, we can handle our drawing routines. So yeah, let's make a virtual size t. Get height, and let's make this a pure virtual function, and let's do the same for the width. So get height and get width, or get width and get height, and I like width more than height, so I put it up to the top. So this is then going to need some documentation. So what's going to be the documentation? So retrieves the client width of the window, and this is important. It's the client width. It's always going to be the client width, so the width that we can use for drawing. And it's the width in pixel. That's also important. And the height in pixel. And also here, height, of course. And I do have a bit of problem with the retrieve word. I always mistype that. But that's the most obvious thing that I would think about when implementing a window. Now, how can we now write a certain window? Well, a window is dependent on the operating system that we are running on. So I want to have a Windows. Windows window.h. So a Windows window. So a Windows window, of course, needs the normal window. So engine core, engine. Why can I not include engine core here? It should. You should be able to solution to your source. I don't know. Okay, I think Visual Studio is a bit blocked currently. Engine core window.h, yeah, I cannot have some IntelliSense, but it still works. That's amazing. Okay, so engine core window. Then I'm gonna go into namespace engine. We're gonna have one large namespace. I do not want to have sub namespacing and things. We want to write a simple engine, so everything in one namespace. Windows window. That's what I want to have. Class Windows window. It's a public window. So that's how we roll. We're going to write a constructor, the Windows window. That's going to need some parameters, or maybe we don't even need parameters. I think we can get away with no parameters, since the window shall be a singleton in our case. So there will be only one Windows and window in existence. So we can get away with just having it like that. So we need a constructor and we need a destructor. Now, we're going to also need to implement our interface, and we need some members. I always like to put my interface in some separate block. Implement virtual methods. Let's go for that, and this shall be here like this and this. Okay, now we are where I want. This is basically how the structure shall be. I do have a bit of an issue there, so let's make this like this and delete this out of existence. Okay, so this is now our boilerplate code that I want to start with. Now the window size, I want to actually save these. So width, what is going to be the width? 920. So let's start with an HWND window, and this one as the height. This is basically how I want to get started, and I can directly return these here because this is straightforward to return. And we just now need to make sure that we kind of like fulfill the contract that this width and height parameter in the class is always valid or updated if needed. This is like the whole like point that we need to implement there. So that we make sure of that works. Now, how do we create a Windows window? Now, in the end, what we need is we need to have a window class that we need to register on Windows. And to register that, we basically need to describe it first. But before we do that, we need to think about our strategy. Now, a window class can only be registered once per application. So if you would have multiple Windows window instances, it would not work. I think we are kind of like confined a bit that we always have one Windows window, but it would not be the most cleanest way. So maybe we want to do it directly the proper way, and we can actually implement this quite easy. We can make a small private block in here and call this one class window registration, or window class registration. We can simply nest one of these classes inside of here. That's really, really simple. And what we can do, or we could even make this one, no, let's make this a class. And what we can do is we can just simply make this one a singleton and do it, but no, actually no, let's make it the easy way. I said I don't want to make things too complicated. Let's register the window class in the constructor. Let's just assert that we are only going to have one window. Now, of course, if we want to use Windows API features, we need to include Windows. I like to have a win include in my project, so there's a win include, and I want to define no min max and hashtag define win32 lean and mean. These are things that I tend to define always, and then we can just include windows.h, and later on we can also include like d3 d12 because that's what we're going to use, and we can also include dxgi 1.6.h, like all of these Windows related headers that we need, auxiliary headers. Okay, now that we have our win include ready, we just need to include it. So engine core, engine windows, and still no IntelliSense for me. That's sad. And now what we should have is we should have the window WND class XW struct. VCX, this is our descriptor that we use to describe the window class. What I tend to do is I tend to go inside here and I tend to just copy all of the parameters that we need to fill. Then I like to just clean them up, and then we can use the power of multi-line editing. Oops, the power of, I did not copy that, damn. But what we could do if I would have not failed, we can use the power of multi-line editing to expand these easy. Now this needs to be the size of VCX, so we need to describe the size of that struct, since the register function can have different structs applied to it, and there's a bit of magic behind the scenes going on from the Windows OS. But what we can design, it's we can describe it like that. So we say cb size equals the size of the class that we are using. Then we need to define the style. This is basically the class style prefixed with cs, and you can already see what I get suggested. CSONDC, that's the only thing we really care about. We need this class to tell Windows, hey, we want to draw on that window, or not we want to draw on that window. Basically, how Windows works, it could be that a window gets not its own device context. This is what this OwnDC says. So OwnDC means own device context. It could be that the context is shared with the parent window, which is super simple and super easy for nested control. So if you have a button, it can share the context with its parent window. So the button basically draws itself into the parent window and does not have its own context that then gets merged together and blended together by the desktop manager or any other Windows parts. However, since we need to expose our window to DirectX, so we need to create like a certain surface that's accessible by the GPU, we need a own DC. The next thing is the window proc. We're going to get to that in a second. Then we have the CB class extra and Windows extra. This basically indicates how many extra bytes are allocated for, I don't know, things. We can put them to 0. The next thing is the H instance. The H instance is actually something that I want to save. So the H instance is going to be relevant during the whole lifetime of the window. So let's put an H instance in here, and what we want to do is we want to basically cache this H instance to the H instance of our application, which we can get by get module handle, and we can just pass null pointer in, which basically means get the module handle for the current active module, which is our exe. And basically what this means is we just gonna associate the class with our application. As simple as that. The next thing that we need is an H icon. We do not need any icon, so we can put this to null pointer. The next thing is a cursor, so we want to put some cursor in here, which we can do by load cursor. We can specify an H instance. We're going to set the H instance to a null pointer, which basically means load the cursor from the system. And IDC is the cursor prefix, and I want to have the IDC error, which means the normal cursor. The next thing is the H background. The H background defines how the background is being drawn by default. Since we will use DirectX 12, we can set it to null pointer, which basically means don't draw the background at all. Next thing is the menu name. We do not use any menu on our windows, like this context bar menu here, but in a not so fancy way, but we don't use it, so we set it to null pointer. The next thing is the LPSZ class name, which is the name of the window class we are registering. I'm going to put that one to GameEngine window, as simple as that. Now the next thing is another icon. We don't need any icon here, so we put it to null pointer. Basically there's a small icon and a normal icon. Okay, so now that we have described our class, we can actually register it. Register class XW is the function that we want to call, and we just basically pass in the class. Now we can either reference the class by this name or by the atom returned by it. I want to use the atom, so atom window class, and the atom is by default going to be 0, and it's going to be assigned by that. So there we go. Now our window class has been registered. Now the next thing that we need to do is we need to create the window, the actual window itself. How do we create a window? Create window XW is the function that we need to call. This is creating a window. This is returning a so-called HWND, which is the window handle that we're actually going to use. So this is a window handle, and we get this by calling this function. Now what does this function take as arguments? And it seems IntelliSense hates me today. There we go. So first of all, it's an X style, a certain extended window style. VSX is the prefix for that, and we want to not get too fancy right now, so I want to have this as overlapped window, which basically means a normal general default window. The next thing is the class name that we need to specify. Actually, we don't have a class name. I mean, we have, this would be the class name, but I don't want to use it. I want to use the window class Adam, which needs to be casted to an LPCW string, but it's okay, that's possible. We can do that. Even this seems a bit odd, but this works. Next thing that we need to specify is the window name. Window name is going to be called game, just simply game. We later on going to replace it. The next thing is the window normal style, so not the X style, which is also VS overlapped window. So VSX overlapped window and VS overlapped window. Now we need an X and the Y position for the window. Let's maybe start at a 10 and 10, and then we need the width and the height. So we're going to have the width and we're going to have the height in here. Then we need a parent window. We don't want one, so let's put it to null pointer. We need a menu, we don't use one, so put it to null pointer. Then we have the H instance and we put in the H instance. The next thing that we need to specify is a so-called create parameter. There we go, like LP void LP param. And this is a pointer that can be anything. This pointer has no means to Windows itself. This pointer is just a pointer that Windows takes, Windows passes around, and at some point Windows forgets this pointer. Actually, to be more specific, this pointer is stored until the window hits the creation where the window message VMNC create is issued. And as soon as this function is issued, this pointer is passed to the window proc, and after that passing to the window proc, this pointer is more or less forgotten by Windows, and we can in the window message do something with it. And we're going to use this pointer to actually bind our class's instance, so our object-oriented approach. We're gonna use that pointer here to bind it to the class instance. So basically what we're going to do is we're going to supply the this pointer, and the this pointer indicates, okay, I'm creating a window for this class instance, and then at some point we can pick this up again into a static function, into a like C style non-object oriented function, and we can pick this one up and see, all right, we have it, and then we can use a bit of magic that you're going to see in a second to bind the window to this class's instance. And this all comes together with the magic of the window proc. The window proc is a function, a callback function that's called when the event happens on the window. So let's implement these. Let's make a private section in here and let's define a window proc. The signature of the window proc is lresult. We have window proc, let's call it as it is. Then we have an HWND window, a uint, the so-called window message. We have an W param, and we have an L param. So basically how this works is the window on which the window proc is executed, because the window class, where we define the window proc on, it's not related to a window. The window class is just a generic class that describes how this kind of windows are handled. And then basically what the window proc picks up is the actual window on which the function was executed. Then we have a message. The message indicates what event happened on the window. And then we have these two parameters, the W param and the L param, that are basically containing the actual data of the window. Now, what are we going to do in the window proc? For now, we are doing nothing in it. So what we do is we send it to the default window proc, which is a function called dev window proc W. And we can just pause all the parameters along. And this is basically how we would need to define a window proc. However, you will see if we are trying to use that window proc in here, it's not going to work, even if we try to sometimes, but this is not functional. So yeah, you can see that it doesn't work. Why doesn't it work? Because this is a class-based pointer. This needs a instance. It's an object-oriented pointer. We need a static function. So if we have a static result window proc 2, let's just call it window proc 2 for now, then you're going to see it will work, because window proc 2 is a static function. However, if we have a static function, we do not have any context bound to our window. And this is now where our this pointer that we passed in the parameters for creating a window will come into play, because we're actually going to write two more window procs. We want to write a window proc called setup and redirect. These are the two window procs that we need. Both of them will be static. A static setup and a static redirect. Now, how does that all come into play? Let's first create the function bodies for these, and then we're gonna go through that step by step. Now, what I told you is that normally, if you put in this pointer in here, it's going to be kept by the Windows API until the event NC create is issued, and as soon as the event NC create is issued, it's after that forgotten. So what we need to do is we need to catch this NC create window and somehow make this pointer persist within the context of our window, so that we then can use it later in the redirect function to pick it up again somehow out of the context of our window, to then redirect all our calls to our actual window proc. So what we're going to do is up here, we're going to start with the window proc setup. And what we're going to do is we need to check until we get the message NC create. So if message equals window message NC create, this is the message we want to pick up, then we want to do something. If this is not the case, well, you guessed it, we're just going to give it to the default window proc. So we do not gonna implement any certain specific behavior before we're gonna hit NC create. As soon as we're going to hit NC create, we do some specific stuff. Now, what specific stuff do we gonna get? Now, what we can do is we can create the so-called create struct. Or not create, but we can get the create struct. The create struct is a structure that defines how the window is being created. And this is stored in case of the NC create message in the L param. This is an 8-bit value, this is not an 8-bit. This is an 8-byte value and this is a 4-byte value. So 32-bit, 64-bit. We are on a 64-bit machine, pointer. This is a pointer. And this is just some auxiliary data. This is used by Windows to have something in here. You can see, actually, is it already? It's a UN pointer currently. It's also 8 bytes. Oh, 8 bytes. Interesting. Yeah, it can be that it changed, but we don't really care how big these are. But in the end, L param is most of the time used as a pointer. It's a long pointer. That's what we normally use in Windows. Now, inside of this create struct, there are many things. If we can take a look at the create struct, you're going to see actually that there's a lot of stuff in there. The create struct is basically everything that we defined on our window. So you can see that we have the H instance in here, the menu, the parent window, the sizes, the style, the X style, the class name, the window name. There's a lot of information in this NC create. Basically everything that we feed it into the create window function. But what we are interested in is this LP create params, because this LP create params is basically the pointer that we passed in here. This is pointer, the pointer to the object. So what I basically want to get is this one, like create struct and LP create params. This is the pointer. However, I do not really care about that pointer. I don't want to really fiddle around with it. The only thing that we could actually already dispatch the call here, but no, I don't really care. What we want to do is we want to create that, we want to take the pointer and store it in the context of our window. And this is actually quite possible because every window has space for one pointer to store, or better to say for 8 bytes to store. Every window that you're going to create with Windows is going to have a so-called user data memory section, which is 8 bytes big to store one pointer or any kind of data that you want as a so-called user data. How can we access that user data? Well, we can set it by calling the set window long pointer W function. We need a window in there, of course, which is the window that we are calling on. Then we need to specify a so-called index, SVLP, GVLP, global Windows, I don't know. GVLP is the prefix for that, and you can see that we have a lot of GVLP things that we can store in, an ID, a parent, H instance, user data, and window proc. But what we want to modify is the user data. So we want to set the user data, and we want to set it to the create parameters. We need to actually cast this to a long pointer, and there we go. Now we casted it to a long pointer, and we can store it in the user data. Now what we need to do is we now need to just kind of like make sure that all further calls or all further messages are no longer processed by the setup function, but are processed by the window proc redirect. So how do I do that? Well, actually, as you saw it and maybe already suggested it, you need to call the same function again, but with the not user data, with the window proc. So actually this window proc pointer contains the address of the window proc that is being hit. So if I would get the pointer while being in this function, it would basically give you a function pointer to that function. But what we want to do is we want to now set it to a function pointer to this function. So what we're going to do is Windows window, and we're going to set this to the window proc redirect. As simple as that, a new function pointer stored in here. And that's actually everything we need to do. Now the only thing that I now like to do is I just want to call the Windows redirect function in here. So I want to call that one so that all further calls, and including this NC create, are actually passed to the redirect one, and so also passed to the window proc. So basically we're going to have a bit of a, let's call it, how do we call it, blind spot. We have a bit of a blind spot in our object-oriented approach. The blind spot is all window messages before NC create will not be seen by the actual class and cannot be handled by the class. And if this function would be virtual, could also not be overwritten by any further implementations. But in the end, this is necessary, and that's the only thing how we can handle that. Now in the window proc redirect, the only thing that we need to do is now need to extract this pointer again. So the window pointer needs to be extracted. How do I get the window pointer? Windows, window, we're going to cast something, and now we're going to call the function get window. Window long pointer W. Now previously we set it, now we're going to get it. I'm going to get it from HWND, and I want to get it for the user data in here. And now we have the window. And then what I can do is I can just say, okay, return window, window proc. And now I can actually call the object-oriented function that we have. And yeah, more or less, that's it. As soon as we get the event, we're going to cast it to the struct, we're going to set it to the user data, we're going to adjust the window proc, and then we're just going to call into window redirect. And in here, we're just going to get the pointer, and we're going to call the actual window proc. And now we have a properly working window. The only thing that's left now is to do some deconstruction, and we're going to see that actually even more is needed, but we're gonna see. Now, before we are allowed to destroy a window, we need to make sure that the window is properly closed and handled. So the first function that you need to call is destroy window. If you're destroying a window, it means that it gets destroyed. And then unregister class, that's something that you should also call. The class name, yeah, okay, lpcuw string window class, so the class Adam that we have, and the H instance. These are the two functions you need to call. You need to destroy the window, and you need to make sure that the class is unregistered. It's not super necessary that you do it, because Windows will do cleanup, but you should always be just sure that you do proper cleanup just for good measures. Yeah, because if you would not do things like that, then you could end up with, as soon as you're trying to use it in an object-oriented approach, the window things would not be going so well. Okay, so that's everything that we should have, and that we need to just get a very, very basic example running. Before we're going to integrate this into the engine, I do just want to put it in here. Okay, so engine, Windows, window, .h. It's just something like that so that we can get started. And now what I will do is I will say engine Windows window. Okay, just want to create a Windows window, and so that we can see it, we actually I can show you what happens if we just do it like that. Let's just do it like that, and let's see what happens. Nothing happens. You're going to see it's finishing. It's not showing anything. Well, why? Because of course our application is directly creating and destroying the window. What happens if I make a while true? Well, where is our window? I don't see any kind of window, and that's actually right. We don't see a window because it's not visible. A window needs to be made visible explicitly. There are multiple ways of doing it. The most easiest way is just defining it with the style. So vs visible. That's the style that we can use to just make a window visible. And there we go. We have our window. But I have multiple issues with the window. Now the first issue that I have is I cannot click it. I cannot minimize it, I cannot maximize it, I cannot close it, I cannot even, I can click on here, I can click close on here, but nothing happens. This window is completely unresponsive. So you can see we have it. It's called game, it looks good, but it's unresponsive. But even does it look good? Well, I said I created you a window that's HD. But my display, my monitor is not HD. My monitor that I have is 4K. I use display scaling. I use a lot of display scaling because I want to show it to you. Basically, I am quartering my resolution. My virtual desktop resolution is quartered. So I actually have like an HD canvas on my window. So every window that's not explicitly telling Windows, hey, I do not care about any DPI setting that has been done by the user. I am raw. I'm a raw window. I do whatever I want. As long as the window and the application is not saying that, I have an HD window, and that's my problem, right? We're having a game. I don't want to have any Windows kind of scaling active. Currently, I'm doing Windows scaling. I'm doing Windows upscaling, which is not nice. If I want to have a game, sure, the user may have some DPI settings that I want to take into account on the UI, but the application itself should be DPI aware. And that's the main issue that we have. We are not DPI aware. And that's actually something that I don't even know out of my mind. So Windows DPI aware Application. Make Application DPI aware. Festlege der DPI-Erkennung für einen Prozess. I don't really care. I think this is what I want. But I do not want to do it in here. Create a UVP. I'm not sure about if this is the right one. But basically, I think this is the right one. Okay, but here, per monitor, what we want to do is a per monitor version. But I think that's the wrong one. WM create. Okay, I'm not sure. Let's just see, because we need to kind of like advertise that we are DPI aware. So you can see like system, DPI aware, DPI scaled by Windows, and per monitor V2 DPI aware, but set thread DPI aware, testing your changes is I think the wrong one that I have. Let's see if I can find it. I really hate that I'm always like forced on a German translation. What we want to do is we want to do that thing, that XML stuff. That's what I want to do. I think we could also try to do it with a function. We could try that. We can try to do it. I mean, they are not recommending that, so we should do it with the DPI awareness. But I do not like these manifest stuff because I think that they are a bit hard to embed. There is, I think, a way to do it with a pragma. I'm not sure. Comment lib, no. I'm not sure. The people, I think maybe there is a way to do it with a pragma. But I think, no, I don't personally really like to fiddle too much with the data encoded into the application, like the, how are they calling it, with the application manifest. The application manifest is a bit hard to integrate a build system, so I personally like to just run a function. And this is what we want to do. We want to per be that value. That's what we want to be in our application, and it's called Z process DPI awareness context. Since we just have one window, we can do it. So be DPI aware. That's what we're gonna try to do. Context set. Now it's a function called, I am super stupid, Z process DPI awareness context. Z process DPI awareness context to that one. Let's see if this works. And there we go. Now I have a proper HD window, because now, as you can see, it's only like a quarter of my screen, which is an HD window. I have a 4K screen, so this means that now the window has been created in a proper way. Okay, so first issue solved, but you can see that this window is still unresponsive. I cannot click it, I cannot close it, anything. The problem is that for a window to be responsive, it needs to be pulled, because Windows is a very, very nice API actually. I really like how the Win API works. I'm really a big fan of Windows programming and everything. in the end, people really at some point hate and say, hey, a Linux machine is more cheap. But okay, in the end of the industry, if you go to like industrial automation, which is the area that I work in, people don't really care, right? Like an IPC with Windows on it, it's like maybe with all of the licenses and all of that, it's maybe like 500 euros more. And if you are on a certain brand of products, you might even not get away without Windows. But yeah, that's a different story. Set process DPI awareness context, simple fix for big issues. Next one, actually polling our window to come back to what we need to do. In the end, the Win API is really, really nice. What it does, it creates this a window for us. But that's the only thing it does. It does not handle that the Windows is handled. In the end, what happens if I start the application and I click on the window, or I try to drag the window, or I try to rescale it, or I try to close it? Basically, what happens behind the scenes is that messages are sent to the window, to that message proc. Basically, what happens if I click, an internal Windows message is being produced and put on the queue for my window. And this message needs to be responded to. And the default window proc is doing a lot of magic. For example, like clicking and dragging so that the window moves, or that the red, the X is colored red. And if you click it, the window closes. This is all stuff that's handled by the window. That's nothing that's like implemented in the OS. I mean, it's kind of implemented in the OS, in the library, in the Win32, I think, user library. I don't know. No, I'm not sure where this is, or shell library. I don't know. Probably it's shell. I don't know. But that's all implemented by Windows already, but it's not something that comes out of the box. And if we don't call the default window proc, it doesn't even come at all. But we call it, but we still not get it. We don't get it because the messages are not polled. The operating system, the desktop manager, everything that's like handling outside of my application. Like this is the terminal, which is not really my application. Or maybe I don't think so. I think it's console host, and there's a lot of magic going around. But there are a lot of other things happening on the desktop. There's Visual Studio happening. I cannot even get back to that window, actually, as you can see. There's a lot of stuff happening here, and all of these interactions, all of these clicking and stuff like that, they are all handled by one operating system component and are then pushed to the queue of the actual window that you are trying to click on. So if I click and drag on the console, it's being put on the queue of the console. If I try to activate this window, it's put it on the queue of our window. And the problem is, our window, we do not serve that queue. And to serve the queue, we need to update our window, more or less. We do not have this as an API, but I want to have it as an API because this is really important. So we have the width and the height, that's important, but what I want to have is a virtual void update. So I want to have a function to update the window. Updates the window. And what we need to do is every kind of like cycle of our application in our so-called game loop, we need to update the window at some point. So every time we do stuff, the window needs to be updated so that everything runs in sync. If I run that, it should no longer be possible to build, but I would wanted to show you how it looks like. So let's do it, void update override. So we have it here. So let's put in the update method. And before we update it, I actually want to show you something, because in the task manager you should see that this has keine Rückmeldung. No, it does not show it like that. Okay, I wanted to show you something, but it doesn't work. Okay, fair point. Okay, so what are we doing in our update function? We need to update our window. And how do we do that? Basically, we need to call our window proc. How do we call our window proc? We do not call it ourselves. What we do is we ask the window queue if it has some messages for us. And then we want to process the message, which is doing some things in the background. And then at some point, if necessary, calls the window proc. So how does that work? First of all, we need a buffer for the actual message. We do it like that. We just create a message buffer. And then what we call is a function called peak message W. What is that function peak message doing? This function is basically peeking into the window queue and checking if it has a message. And if it has a message, it's going to kind of like put it into the message buffer, and if there are flags defined, it's also going to remove it. Let's go to that step by step. So first of all, we need to define the message buffer where we want to peek the message into. Then we need to define our window, which is our window. We need to find some filters, so message filter min and max, we don't really care, let's put them to 0. And then what we need to specify is a v remove message, and this can be pm remove, or I think pm no remove or no yield. There are actually a lot of flags that are available for that, but there's like the most important one is no remove, which would basically mean, hey, take the message, put it into the buffer, but don't remove it from the queue. Or what we can say is PM remove, which basically means check if there's a message. If yes, remove it and then go on. And what we want to do is we want to have exactly that behavior. We want to peek, and if that peak is successfully, or actually not even if, as long as this peak is possible, so as long as we can peek some messages from our queue, as long as we have messages available, we want to remove them and put them into our message buffer. And now we need to do certain things with the message. First, we need to translate the message. Translating basically means that the raw message details are taken and they are like transformed into a way that the application can later on understand them in our current configuration. And then what we want to do is we want to dispatch the message. And when we dispatch the message, we basically send it to our message proc. There might be some more things going on in the background, but dispatch message is more or less taking a look at what's the window or the message was being handled on, what's the message proc, and then it is doing some dispatching work for that. And that's basically everything that we need. And of course this needs to be called, so while true, window dot update. So we need to update our window. And if I now run that code, you can see we have our window, and now you can already see that if I hover over these, that I get the nice colors, how it's expected. I can take the window, I can drag the window around, I can minimize the window, maximize the window. You can see there's even an icon. Go like this, go like these, go into here, drag it and do a lot of things, and it more or less works. However, we still have some issues. First issue is not actually a real issue. You can see that the window is not drawn incorrectly. You can see these lines, and if I minimize and maximize that, it's then black again, but it's not always working. It's doing that. If I drag slowly, it's completely white. If I go a bit mad, it looks like that. This is actually expected. We are not actively drawing anything in the window, and we are not even specifying the OS that it should like clear it to a single color. But that is all okay. That's all good, because yeah, actually it's not a problem, because we want to do it with DirectX. However, we have a few more issues with our window. You can see that I can resize the window, but of course, our member, let's go into the header, our width and height, they are not updated. That's something that we need to fix. And we have another issue actually. If I close my window, well, our application is still running. If I close the window, we are running. That's not good. We should terminate our application if we are closing the window. And yeah, that's something that we need to take care of. Now, both of them come down to responding to the window proc actually. Now, everything that happens on the window is sent to the window proc, to that one down here. Let's not consider these. We have implemented these. We don't want to change them. Everything is sent at some point to this window proc. Now, what we want to do is we want to respond to certain messages. So what we're going to do is we're going to do a switch on the message. And we want to respond on the WM close message. And let's make a break in here. And we want to respond on the WM size message. Now, as you can see, it's directly indicating what we want to do. We want to do something if we are sizing, or not sizing, if we have sized the window, resized the window, and we want to do something if we want to close the window. Now, closing the window is not actually going to be what you think it is, but sizing is going to be quite what you think. If we are sizing, we just need to update internal variables. But closing is a bit of a different story. How do we want to handle closing of the window? And actually, the whole point in closing the window is we don't. Quite simple. If we're closing the window, we don't do it. And exactly this is what we do if we return 0, because we are not calling into the default window proc, which would actually hide and close the window. Now we don't do it anymore. Now you can see that the window is no longer closable. You can even press Alt F4. No, it doesn't work. The window is not closable. And now what we need to do is we just need to make it closable again. And basically what I will do is I will catch if the window has been closed. So we have width and height, and then we have a boolean in here, m close requested, which is going to be false. So as soon as VM close is pressed, I'm going to set my close requested to true. So now as soon as you press the X, a close is requested. Now we just need to get this into our main application loop so that we can terminate our main application loop. How are we doing it? Well, we adjust our contract. We're going to go in here and write a new virtual function, this time a Boolean function, close requested. And now let's add some documentation. Returns true for one time after the user requested the window to close. True when close was requested. And that's a very, very important contract that we are designing here. We say that this function shall return one time true after the window, after the user clicked the X. And we can easily implement that. It's just going to be a very, very simple Boolean based logic. Yeah, let's do it like that. Bool close requested override. Okay. Let's go in here, let's implement that, and the logic behind that is really, really simple. Should close, or yeah, let's call it what it is. Close requested, and then we clear it, and then return close requested. Why do I want to clear the variable? Well, I just want to clear it so that we don't end in a deadlock. In the end, if you call close requested, it returns true, and you are kind of like not reacting to that, it will basically call it into an infinite loop, and if you don't want to close it, the user one time clicks on it, it latches, and it's a problem. I do just want to like detect the edge. The user closed it, then maybe the game displays a message internally and says, hey, do you want to really close the game? And then if you say no, it should not fire directly again, so it should just be there for like one time. So one time the user pressed X or tried to close, this should be handled. And that's very, very simple. Close requested is done now like this. Now in the main loop, we basically just do it like here. While not close requested, update the window. And if we run it like that, we have our window, we can drag it, and now we can actually close it again, and it actually closes out. We are out of debugging, it does now work as intended. Now the only thing that's still left to do is the VM size. So how can we handle a VM size? So we could consider the documentation, because I always get them mixed up. If we look for VM size, which is a window message, you can actually see that it carries a few informations with it. It actually carries in the lparam the low order word of lparam specifies the new width of the client area and new height. So this is actually already what we want. Low order word width, high order word height. So we already have the width and the height of the new window. So basically mwidth equals low word of lparam. Low word is just a macro to extract these, and that does the bit shifting for us. And the high word is going to be the new height. However, this is going to be a bit of a problem, because the width and the height can actually become 0, or it can become smaller than what DirectX supports. So what I personally tend to do is I just tend to put an if in here to just check if they are bigger than 64 pixels, or I think bigger equal is more appropriate. So if they are both bigger equal than 64 pixels, then I will update them internally. If they are smaller, which can happen, for example, if you minimize it, the window is going to get a VM size with 0, 0, because it's basically closed. And yeah, this is basically what I do just want to catch here. If it's 0 or if it's too small for DirectX to handle, we're just going to ignore that it has been sized. Again, that's basically everything that we for now need in our loop in here. What we could do just to make it a bit more easy, let's maybe include a thread and IO stream in here. And what I want to do is I just want to do a quick std this thread sleep 4, which of course requires us to using namespace std chrono literals, let's say 100 milliseconds in here. And then what I want to do is just std cout the width of the window, get width, and then I want to have the height, get height, std end line in here. and this should just now periodically spill out our window dimensions, which you can see that we already got. And actually what you can see is that they are not even HD, what we specified initially. But if I go in, make it bigger, you can see that the number here on the right, the height changes. So 1890 is on the width, and now it's 995. So you can see that the arguments are actually changing if we are moving the window around. And yeah, everything is kind of like according to plan. A really interesting behavior that you can see if I click and drag, it's not updating the console. This is currently because basically as long as you're dragging, it's constantly firing the a certain message. This is something that you could avoid by basically limiting how many messages you are allowed to pull in one loop, but I think for now it should be fine. Yeah, but that's basically how it works. You can see it do work quite nice. The only problem that we have is that our window does not initially start with a client area that is HD, but that is not currently too much concerning. We get the sizing message once if the window is created so that we have the proper values, and that's everything I really care for now. Later on we of course need to have precise control over how we create our window if we're going full screen, or better to say borderless full screen. Okay, so that's everything that we need for the window. Maybe we should integrate this directly into the engine so that we do not use the Windows window. Maybe let's do it. In the engine core, what I want to have is I want to have an engine context.h. Engine context. Engine, like that. And then I just want to have a struct engine context. This is basically our one and only single engine context. And what I want to do in here is engine core iWindow.h, iWindow.h, and inside of here we're going to have with include memory, have a std unique pointer of an iWindow in HWND. So basically I just want to store all of my, maybe let's do it like that. Let's nicely describe it like that. So this is basically our core struct that defines all engines subsystems, and what we need is to retrieve this. So engine context reference get ctx, or maybe we just say a get, so engine get, and then you get the engine's context. Retrieves the engine's context, reference to context, and this is what I want to have. So let's create an implementation for that. Reference to context. Actually what we could do is we do not even need, we do not even have to have an implementation for here. Let's make this an inline. Let's make it a static engine context ctx returns ctx. It's as simple as that. We don't need any CPP file for that. I think it's fine to have this inline. And now basically what I want to do, instead of going to the window like that, so auto reference window is going to be, we're not going to include that one, engine core, engine context h, and it's going to be engine.get .window dereferenced. So this is basically what I want to do, so that I can work with the engine on a very, very generic way. However, as you can see, there is still something missing, and actually what's missing is to initialize the context, because if I would now start this, we would basically get a null pointer here, because the window was a null pointer, so a window is not in existence yet. And what we need to do is we need to make sure that this is all properly initialized, and I of course don't want to have the initialization code in the actual game, or maybe I want to have it in the game, but I don't think that I want to have like these core initialization in the actual game, like the creation of all these pointers. I think that I want to have these ones done in a kind of like static way. So there should be two more functions. There should be a void init and a void shutdown. So these are our two engine functions. shutdowns the engine's systems, and this one shall be a init the engine's systems, and maybe we should have an implementation now. So let's maybe create an implementation here, and I want to go in here, create the implementation. Maybe we even want to move this now to the source file, because we now have a source file, and then I want to create it here. And normally what I would do now in here is OS in, let's make it to do OS independent init, and then in here OS independent shutdown. And then we would of course need to make it OS dependent. So let's fix that here. Let's define quickly two functions, namespace engine. Then I want to have an OS init in here and an OS shutdown. And then what I go in here is I want to go into the engine windows. And in engine windows, what I want to have is a windows engine.h. And Windows engine.h is going to have a namespace engine, and inside of here we're going to have a void OS init and a void OS shutdown. And this is basically a Windows specific init and Windows specific shutdown. And then what we're going to do is we're going to implement, create a file, the actual implementation. And what I want to have is include as engine core, engine context.h, and then do I have created a file? Yeah, I've created a file. And then inside of here, we need to create all of our OS specific things. So hashtag include Windows window and engine windows window, and I would say engine. I think I can just call the get function directly, and I can say this is a new I window, but this is a Windows window now, so I can make this one unique. And in here I can say get window dot not sure if reset is the right function because it takes a pointer, or is it? Yeah, it's the right one. And I would just make sure that the shutdown is also resetting this. And inside of engine context, basically first the operating system needs to be initialized, then the shutdown needs to be happened, and then the OS shutdown happens. So now I basically have all of that together, and then the only thing that I need to do is I need to say engine.init before I start everything, and at the bottom down here I would call engine.shutdown in here, so that everything is cleared successfully. And if I now run that, we now should get back our Windows window in here, but it's completely decoupled now. We are now only at engine core, and that's the whole idea. Engine core is going to be used by the client, by the game, and this is just the implementation that's there for Windows and that we should not really care about. And what we now have is a window. Yay, we have a window, we can move it around and close it, and it's cool and nice. Okay, so thank you for watching, see you in the next video, make sure to like and subscribe, and have a nice day. Bye.